Dang, that was kind of interesting. All right, I'm listening. You said a business account is better, it's faster?
Right. Like a lot of the speeds are faster when you have business internet as opposed to home-based because they throttle the speed, you know, for the residential customers because the business customers pay more for the same connection. So a lot of times the business accounts are faster and more reliable.
Yeah. Yeah, mine seems to be pretty fast though. My what's this thing called? You know, the one that everybody knows, Infinity.
Yeah, a lot of home. I'm not saying that home connections are slow.
Yeah.
I'm just saying that they cater towards business clients. So I mean, they can get faster speeds for business accounts than, you know, more bandwidth for business accounts than residential. But nobody should have real problems with their residential internet unless they like a dial-up, way out in the mountains somewhere where they can't get high speed.
Yeah, I know what you're saying.
So I see Catrice is signing in, Darby's with us, Malika. Hi, Malika. Sophia looks like she may not have sound that I see yet. Yeah, so we'll just give everybody, it's only 8:01, so give people time to get signed in. Let me see. Can you see the PowerPoint yet? No, wait a minute.
I see something now. I see something there. It says Elite MoJo 1Q2015 A+ certification, and it says the name. But the PowerPoint is covered by this big gray stuff. But I sort of see it. I see motherboard and CPU, then I see this gray. Oh, now it's there. Now I see it.
Okay.
I'm your eyes. Yeah. I'm your eyes.
Are you? Thank you very much.
I tried.
Okay, so who do we have that called in on the phone? I see a call-in user 3 and a call-in user 4.
This is Frederick Nevins.
Frederick Nevins, how are you? So you're not on the computer?
No, I'm not able to get to a computer right now.
Okay, so do you have the book in front of you, the PDF of the book?
Yes, I have that on my phone.
Okay.
What's going on?
Who's that?
Did you go and do the email? What through the email?
Wait a minute.
Okay, but I'm telling you it's not working, so I'm taking another route.
Okay, I'm going to ask, if you called in on the phone, then I want you to mute your phone as opposed to me muting you, because if I mute you, then if you want to ask a question or something like that, I won't be able to hear you because I'll have you muted in the system. So if you called in on the phone, I need you to mute your phone until you're ready to speak. And everybody should be muting themselves until they're able to speak to reduce the background noise that we have going on. We have some background noise, got some feedback. I hear somebody typing. Okay, so you know you can always unmute yourself when you want to speak. And whoever called in on the phone, like I said, I'm not going to mute you on the system because if I do that, then I won't be able to hear you if you have a question or you have something to say. It's
Hello?
8:00. Hello?
Hey, how you doing?
Is that Shango?
Yep, sure is.
How are you?
I'm doing good. How are you?
I'm doing well. This is MoJo, but I'm signed in as Peter because he signed up for the account and he named it after himself. And so last time he signed in and then gave me permission, but I signed in. And you can turn your video cameras off because it's going to reduce your speed. You know, it's going to use more bandwidth to use your camera, and we're not really trying to look at each other. We don't have to. So, okay, somebody got down. Carlton, is that you? Yep, that was Carlton. Catrice, it looks like she's still trying to get sound. You got a nice group. Sophia, it doesn't look like she has sound either. So if you're on the computer but you don't have sound, you can type into the chat room so that I can so everybody can see and respond. And Catrice, I know you can hear me and you just typed good evening, but you sent that to me privately. So you just want to check next to send to the checkbox and change it to everyone so that everybody can see your messages as you send them, and everybody just, Darby, you too, you sent the message privately, Roderick, everybody should click on the drop down next to the send to and make sure it says you have everyone highlighted as opposed to just me or Peter.
I hear her.
Okay, who is that? Sophia, you have sound now.
Yes, ma'am.
Okay, good stuff. Okay, so like I said, I want everybody to mute themselves so that we don't have any background noise. Mute yourself. Go ahead.
Okay. Mute my cell phone, right?
No. I'm saying on the system. You're on the computer, right?
Yes.
Okay, yeah. I can mute you, but you see, I don't know if you can see right next to your name, it has the microphone. When you click on it, it mutes your, it mutes you so that we reduce the background noise, and then you just unmute yourself whenever you're ready to speak or want to ask a question or have something to say. And, of course, everybody has the option to type into the chat room. Dag, we have a definite full house tonight. I see that, Catrice. Catrice, you don't have sound. Do you not? Do you have headphones, or I guess you're logged on to the computer? But
I'm actually on the computer, but my headset, I don't know, I couldn't get sound through my USB headset, so I called in. But I'm actually on my headset calling in because I'm under my Google account, so I don't know, I think WebEx is acting kind of funky tonight.
So you're calling user 3. I see.
Yes, ma'am.
Okay, so you do have sound. That's good. Okay, so like I said, if you called in on the phone, I want you to mute your phone as opposed to being muted on the computer so that if you want to speak, you know what I'm saying, you could just unmute yourself. Because but you have access to the computer too, so you can see and unmute yourself too. But like sometimes people just call in, so if I mute them, then they have I can't hear them if they're trying to speak. I don't know if they want to jump into the conversation because I have them muted. So they could be talking, but because I have them muted, I won't be able to hear them. So usually if people call in just on the phone, then I have them mute their phone as opposed to muting themselves on the system. So we are at 8:09, just about 8:10. So we're going to get started. As usual, we are, wait a minute. Okay. Oh, yeah, we're recording. Can everybody see the PowerPoint presentation?
I can.
You said you can or you can't?
Motherboards and CPU.
Right. Okay, and
Yes.
Shango, you're still typing to me privately, so you need to hit the drop-down button so that you could change it to send to everyone, so that when you send messages, everybody will be able to see it, because if you don't, then it'll look like I'm answering questions that nobody else can see. So you just change the drop-down to everyone. So did everybody do their reading/homework? Who's laughing? Somebody's laughing, meaning they didn't.
This is me, Rayco. I didn't.
Okay. I think I just added you though, right? Were you you were in the last class?
Yeah, I was in the last class, but the connection was so bad where I was, but I was listening to bits and pieces.
Okay, okay. It's all right. You'll make it
But
up.
I did download the stuff that you put on Facebook.
Okay, okay. So we're going to start the class with reviewing the questions from Unit 1. Unit 1 was safety procedures and power supplies. So the first question was, what type of fire extinguisher should we keep handy for computer fires? And you can type your answers into the chat room. C.
Can I ask a question?
Yes, who's that?
This is Frederick.
Yes, Frederick.
Like I said, I'm not on the computer, so I won't be able to type in my answers.
Oh, okay. So, I mean, you could just shout it out if you know it.
Okay.
Okay, but mostly everybody says C. And for this instance, the selection C was also Class C, which is the kind of fire extinguisher that we use for computer fires. Class C. So the answer was C. Number 2, what type of fire extinguishing substance interrupts the chemical reaction of burning materials? And we are halon. Yes, halon is correct. And halon was actually C. Let me see who I need to mute. Wait a minute. That is Rayco. I got you. When you're ready to speak, you can just unmute yourself. You had a lot of noise going on in the background, so I had to.
But the carbon monoxide extinguisher works as well, is that correct?
You said what? I'm sorry.
I was reading it said the CO2, the carbon dioxide extinguisher is designed for Class B and Class C fires as well?
Yeah, some of them, but primarily we want to use halon. Is that you with that background noise, Carlton?
Oh, it could be mine.
Oh, okay.
I'll mute when I'm not talking.
Okay, yes. CO2 does put out some electrical fires, but the main one that we want to use is halon.
Okay,
So
I just
in the
double
answer,
check.
right. Okay.
Thank you.
You're welcome. Number 3, true or false, you need to be concerned about electrostatic discharge because it can be fatal to humans. True or false? Okay, we got mostly falses and a couple of trues. The answer is false. And if you go back to page, I had it written in my other book, and then he sent me a new book, and now, so I have 2 books. So if you go back to page 1-2, it says electrostatic discharges aren't dangerous to humans, even though the voltage in the system can measure in the range of thousands of volts. And remember we talked about the differences with the 3,000 volt. You know, you can feel a static of 3,000 volts, and then 8,000 volts you can see a spark, and then 35,000 volts is like high, so you might shock somebody or feel it, but it's not a danger to you. But as little as 30 volts can cause problems to the internal components of your computer. So it's not dangerous to humans, but it is dangerous to your computer components. True or false? Laptops are meant to be used on your lap. No, no, no. Alita, you said true. It's actually false. That's why they're going away from calling them laptops now, and they're calling them notebook computers, because laptops can actually cause burns on your lap because of the fact that the components can overheat due to the lack of airflow through the openings that's on the bottom. And you could get burned by placing a laptop on your lap. And like we said, putting it on the bed, on top of blankets and stuff like that. That's how a lot of dorm fires start and stuff like that, because of the heat. And if the vents on the bottom and the fans on laptops are usually on the bottom too, which is so crazy for me. But blocking it so that no air is getting through, the components heat up and it can cause a fire. Next question is, true or false? Batteries, toner cartridges, and ink cartridges can be disposed of in landfills without any consequence. False, 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 false. The answer is false. Many batteries contain heavy metals that can't be sent to the landfill. The batteries in the equipment might contain nickel, mercury, cadmium. Toners are usually a mixture of plastic resin, iron powder, and carbon, so all of those elements don't belong in the landfill. And like I said, they can trace components back to companies, and companies get fined for dumping and not recycling things properly. And there's a lot of different places like Best Buy, or you can look up in your local municipality where they collect and take in and recycle electronic components. Which of the following are conductors? Choose all that apply. A, ceramics, B, gases, C, liquids, D, metals, or E, plastic. Okay, so we got C, D, E. We got a DC. Who is that? Pierre, you said all except plastic. Plastic is actually one of the correct answers. The three correct answers were C, D, and E: liquids, metals, and plastic. And I try to go back and show you the page, you know, where you can find the correct information so that you can read it again when you get a chance. And that one is one page. See, I had them all written on there, and then I switched books. So it says conductors permit the flow of electricity. The most metals, some plastics, and some liquids are conductors, and that's on page 1-16. If you want to write it next to the question. Oh, if you want to notate it somewhere, I'm thinking that you're dealing with actual paper. So the next question, number 7, is which of the following are insulators? Choose all that apply. Ceramics is A, B is gases, C is liquids, B is metal, and E is plastic. Right. All the correct answers are A, B, and E. Plastics actually fall into both categories, as a conductor and as an insulator, which is weird, but it's true. So it will be ceramics, gases, and plastics. You guys hear that noise? I'm not tripping. Wait a minute. Is it me? It has to be in my ear because everybody else is muted. I don't know what it is, though. Okay. The next question, number 8. Which of the following is a derived quantity that you can calculate by multiplying the force of electricity caused by a difference in charge at 2 locations and the measure of the flow of electrons past a given point?
Say that again?
I feel like this question, it says, which of the following is a derived quantity that you can calculate by multiplying the force of electricity caused by a difference in charge at 2 locations and the measure of the flow of electrons past a given point? Pierre, do you have the unit, the paper in front of you? Pierre?
Oh, the paper in front of me? No, I don't have the paper in front of me.
So you didn't download the unit 1?
Oh no, I have I downloaded it, but I don't know which one it is. Now I see it's unit 1. I'm looking at it now. I just opened it up. So.
Okay, so we're doing the questions from unit 1, which are on page 1-28.
1-28. Okay. Let's see.
Now, the crazy thing is, the difference in charge at 2 locations and the measure of flow of electrons past a given point is current. But it says that the answer is electrical power. So we have to go back to right. So it says current is a measure of the flow of electrons past a given point. So I'm trying to see how this book says that the answer is electrical power, which is confusing me because I thought the answer was current. You have to do some research. Okay, so this book says that the answer is electrical power. So we're going to put an asterisk next to that. No, it's not voltage, Carlton. It's definitely not voltage. Because if in the chapter where we talked about electricity, on page, you see where it says voltage is the force of electricity caused by a difference in charge at 2 locations. See, it's like the question is a combination of both. Because it said, and then it said past a given point, which is the current. So, yeah. Oh, no, look, on page 1-17, right, it says electrical power measured in watts is a derived quantity you can calculate by multiplying the voltage by the current. So then electrical power is multiplying the voltage by the current. So electrical power is the right answer because it's multiplying the force of electricity caused by the difference in charge, which is voltage, right, by the measure of the flow of electrons past a given point, which is current. And that gives you electrical power. I thought I was going crazy for a second. So now y'all get that is multiplying the 2. Yes, no, maybe so. Can you guys hear me?
I can hear you.
Okay. Nobody responded. That's why I'm like, make sure people can hear me. So number 9 is, which of the following is a force that opposes the flow of DC through a conductor? Resistance. Resistance is correct. Number 10, which of the following is measured in amps? Current. Current is the right answer, A. Which of the following is measured in ohms? Choose all that apply. A, current, B, electrical power, C, impedance, D, resistance, or E, voltage. C and D are correct.
I've never heard of
impedance and resistance. You said you never heard of
impedance before. I've never heard of that.
It's the same thing as resistance, except for one is for DC and one is for AC.
Oh, okay. Impedance is the alternate current. All right, got it.
Right. Resistance is the force that opposes the flow of DC through a conductor. Impedance is like resistance but applies to AC. And that's on page 1-17. What is the formula relating voltage, current, and resistance? A is I equals V times R. B is R equals V times I. C is V equals I times R. And D is V equals I slash R. And you are correct. The answer is C. V equals I times R. And that's how you calculate the current. V is the voltage, and I is the current, and R is the resistance. True or false? At a given voltage, current increases as resistance drops. True. Number 14, the power requirements of a motherboard are estimated to be which of the following? A, 5 watts, B, 10 watts, C, 30 watts, D, 50 watts, or E, 100 watts. All right, y'all was doing your homework. I'm so proud of y'all. The answer is C, 30 watts. Number 15, which of the following components requires the most power? A, an adapter card, B, the CPU, C, the hard drive, D, the memory, or E, the motherboard. And the answer is E, the CPU. Very good, very good, very good. Let me see. Okay, everybody. Okay, yeah, that was the previous question. Okay, number 16. Which of the following is a serial ATA power connector or SATA? That's what they call it. Is it A, B, or C? Right. The answer is A. So,
hey, what did you say the other name was?
Which name?
You said something about that's what they call it.
SATA. It says serial ATA or SATA.
Oh, SATA. Okay, thank you.
Right. So what if everybody's looking at the pictures, B is what kind of connector? You can type it in. If you know. Molex is correct. B is the Molex, A is the SATA, and C is the Berg or floppy connector. You have a question? Okay. Okay, and the last question was, which color wire is typically connected to the ground? A, black, B, green, C, red, or D, yellow? A, because we always bet black, right? Okay, so anybody, that was really good, guys. Everybody was paying attention. Everybody did their reading. Mostly everybody, passenger 57, right? Did your reading and your homework. Good stuff, so we can move forward. Does anybody have any questions about the safety procedures or power supplies and electricity?
This is Chandra. GPU wasn't one of the choice answers for which part uses the most electricity. But if it was the GPU using the most electricity, and why does the CPU use the most electricity out of the choice answers?
Wait, you breaking up. I didn't hear your entire question. I'm sorry.
For question 15, it says, which of the following components requires the most power? Why is it the CPU that requires the most power? And if a graphic, if a GPU was one of the options, would that be requiring more power than?
Well, nowadays, because of the powerful video cards that a lot of systems are using, like that gamers use and stuff like that, the wattages may vary, so they may pull a lot of wattage, but typically it's the CPU because the CPU does the most. You know, the CPU is the brain of the computer, so it does all the operations and computing and everything else. So that's why the CPU pulls the most power, because it's the central component, and everything, all of the rest of the components are connecting to the CPU in some kind of way, you know, to make things function. So that's why it draws the most power. But you know that we're moving towards the green environment, and so they're creating a lot of different computer components that use less power, because that's what they're aiming towards, more speed, but less power consumption.
Oh, thank you.
But because the CPU is central to everything that goes on, that's why it consumes the most power. Right. I want to make sure I'm not missing anybody's questions before we move forward. Okay, so Unit 2 is motherboards and CPUs. So in this chapter, we're going to differentiate between the motherboard components and explain their purposes, differentiate between CPU types and choose an appropriate cooling method, and then configure and apply BIOS settings and install and configure expansion cards. Everybody that's on a computer, you can see the PowerPoint presentation. A lot of times I'm not clicking on it, I'm just going from the book and moving forward, but I'll try to keep clicking. Okay, you guys can see, that's good. Okay, so topic A is motherboards. So the motherboard is the main circuit board of a personal computer. It's made up of various components, including the CPU and other electronic devices, wires, adapters, and sockets to which additional circuit boards and devices can be attached. So here's a picture of a standard motherboard. And if you guys can see my, I guess you can see my pointer. It has, it's like laid out like a city. Like if you actually look at the motherboard or on the, actually on the green of the motherboard, everything is labeled. It'll say PCI slots over here, and it'll say DIM 1, DIM 2, DIM 3 over here, and floppy. Everything is labeled. It looks like a little city. And so the socket here is where your CPU will go, and this is the backside where you see all the ports that are usually coming out of the back of your computer. And these are the different slots. The PCI slots are expansion slots, and we'll talk about that. The BIOS, the CDN connector, the CMOS battery. We're going to talk about all those components. But this is a picture of a standard motherboard. And it's like the central, everything that is in the computer connects to the motherboard and connects to the power supply. And this chart shows a typical list of the different components of the motherboard. So we all know about the CPU. Expansion slots, we'll talk about that, how you add different components to the computer. Hard drive connectors, floppy drive connectors, the power connector, memory slot. PS2 are the standard mouse and keyboard, but the green and purple. A lot of systems are moving away from them, even though a lot of motherboards still have those ports. Most people have a mouse or keyboard that are USB. And then, of course, USB ports, that's one of the most popular ports. Stereo and parallel, we'll talk about. They still talk about them, but we don't use them as much as we used to because most things have moved to USB. The CMOS battery, we'll talk about what that is. The network interface, video connectors, all of that are components of the motherboard. And on page 2-4, it has this chart and a list of functions of all the different components, right? So we're going to cover all of the different kinds of components, so we're not going to go through this list, but you can read it for information purposes. And then, because going through the book, we'll go over all of these different components of the motherboard. So sometimes they call a motherboard the system board or the main board, but the latter term is typically used to describe the main circuit board on non-PC devices such as alarm systems, televisions, and so forth. Because the reality is, all of the devices and stuff that we use today have some type of central computer. So they all contain some type of main motherboard, circuit board, whatever you want to call it. You know what I mean?
No.
Down.
Don't mean to interrupt. I can't see your PowerPoint anymore. I'm not sure if you're doing that by design.
No,
Yeah,
I didn't do it by
it says
design.
Premiere.
Wait, that's you?
No, this is Carlton. It says the host is Premiere.
Yeah, my connection is jumping in and out and that's the reason why the PowerPoint disappeared, and hopefully it'll pop back in. But I'm not connected to the meeting right now. Some type of error happened, and I don't understand why it keeps happening. But it's attempting to reconnect, so it'll be back up in a second. So like I was saying, most of the things that we deal with today have a motherboard inside, from your TV to your cell phone. And so like we talked about the fact that this course is about PC technicians, but when it's all over, you'll be able to fix, like we do, changes to iPhone screens and stuff like that, because because they're all basically, they all function the same way, just on either a larger or smaller scale. And they all contain a board, a motherboard, whether it's large or small. They all contain it. Can you guys see the display now again?
Yes.
Okay. So daughter boards, we're not really going to see a daughter board again, but a daughter board it was a circuit board that you would connect to the motherboard, right? But it was additional function. So it used to be, in order to add a video card, you had to add a daughter board to it as an extension of the motherboard to be able to plug that video card in. We don't do that anymore. They have video cards that are standalone, expansion, all on their own, and, you know, we're able to add different components without a daughter board. So it was like a mini circuit board connected to a board to add additional functions. But because of the expansion and the advancement of PCI and the different kinds of expansion slots, we don't use daughter boards anymore. So form factor. If you remember, we talked about form factor with the power supply. And the form factor is in relation to the size and shape of the motherboard. And that dictates the power supply and case that you need. Remember I said it's like a triple. You need all three, and all three have to be the same form factor. So if you have an ATX power supply, you need an ATX motherboard and you need an ATX case, because the ATX case is ATX motherboard won't fit on a micro ATX case, and a micro ATX power supply is not going to fit into an ATX case. So when you're building your system, form factor is very important, and you have to match the form factor of the motherboard to the power supply and the case. And it has a list of the common popular form factors of the motherboard, but the most that you see nowadays are ATX and micro ATX. And for me, the easiest way for me to differentiate between the micro ATX and the ATX is that the micro ATX is 9x6 by 9x6 is actually a square as opposed to a rectangle. So that's how I differentiate between the two. How will a person know which one it is? They're labeled. When you go shopping for PC and components, everything is labeled. So when you open a computer, remember I said try to get an old system that you can work on. When you open it and you pull that power supply out, or you pull a motherboard and you look at the case, it says it on the power supply that it's an ATX power supply. And so when you're shopping for components, and like say you're on Amazon.com and it says, you know, ATX motherboard for sale, you have to click it and make sure that it's actually ATX. Sometimes you search for ATX and micro ATX boards will show up in your search. So you have to make sure that what you're purchasing is in fact an ATX or micro ATX motherboard compatible with your ATX or micro ATX case and power supply. But everything is labeled. And when you search and you're shopping for computer components, because you know now, you know, as you're taking the course, you know this information, then you know what to look for. So now you know if you're looking for, first of all, you'll know now looking by the size. You know, a motherboard, if you're looking at the specifications of it and it's a 9x6 by 12, it's an ATX. If it's a 9x6 by 9x6, then it's a micro ATX. So by size and by shape, for me, the micro ATX is a square as opposed to rectangle. And those are the two most popular you see. The Nano and the Pico and the Mini, they were all smaller. You know, people are always trying to go smaller and smaller, but still faster. And a lot of smaller boards will be used in, like, those very, like, you know how they have low-profile systems, maybe at offices, they have really small horizontal towers as opposed to the large vertical cases, and they're really small. They usually have one of the smaller form factors of motherboard in them because they have limited functionality. They're used just for a specific purpose. Just like if you like computer kiosks and stuff like that you've seen out at the mall or stuff like that, it has a motherboard inside, but it's depending on the size of it. It's small because they have a specific function, so it doesn't have to be all that advanced. And it also limits how much you can expand it because of its size. So it has less ports, less expansion slots, and less size that will fit in whatever case you put it in, you know, so it wouldn't have as much expansion capability as a full-size board inside of a full-size case. So form factor, very important. Match the motherboard to the power supply and the case. Everybody clear on form factor and how to identify the form factor? Everything that you purchase is labeled. And when you're shopping for components, you know what to look for. And we're going to do that. In a sandbox, we're gonna build a system. So we're going to go online, and we're going to find the power supply and the case and the motherboard and the CPU and the memory, you know, and put it all together because everything has to be compatible. Certain boards take certain kinds of memory. A board takes certain kinds of CPU. You can't just take any CPU. They're all matched. So even though a motherboard comes in a certain form factor, it's only made to be compatible with certain CPUs. You might have a motherboard, an ATX motherboard that can only use these specific AMD processors. Just like when you say, like say you putting your system together and you're like, I know I want an i5 Intel processor. Then you have to make sure that you purchase a motherboard that's compatible with an Intel i5 processor. It can be ATX, but that includes laptops as well as desktops. Most definitely. Laptop boards are smaller because it's inside a laptop, but you also have to find boards and you have to match the processor to the board that you purchase. So everybody clear on form factor. Makes sense? Okay. So that's very important, the big three. You know, you got to match those three things to put the system together. So,
I do have a question. So does that also go with like the different casing for a computer? Like an ATX can only go in certain casings, and a mini ATX can only go in certain casings, and that sort. Does that also go with that?
Yeah, that's what I said. The three is the case, the power supply, and the motherboard are the three components that have to all be the same form factor.
Case,
like I was saying.
Okay. Now,
you said what?
The case, the power supply, and the motherboard. Now, the power supply, isn't it just one power going to every computer, which is, I guess, 112 volts or something? So I'm not really certain when you say the power supply. What you mean by that exactly?
So you wasn't here for last class, right?
Oh, sorry about that. I'm gonna review that thing. Listen.
I was making sure you listened to the recording from the first class, because then it talked about the function of the power supply in a computer is to convert the 110 volts from the wall to however many volts that each specific component needs.
Oh, so it's a converter. Okay, I got it now. So each converter, each computer has a different supply of power that it needs, and a converter is the one that makes what the computer needs, which is more or less.
Don't confuse yourself. Don't confuse yourself with the converter, because the converter is a whole other thing. So just understand the Shango, the recordings are posted in the Facebook group. I added you like last minute right before the class started, so we'll get I'll make sure that you get the link to the recording from the last class. But the power supply, if you go back into Unit 1, it shows the power supply has connectors that go from the power and a whole bunch of different wires and a whole bunch of different connectors. So the power supply converts the DC power from the wall into the power that's needed for the individual components at different voltage levels. So the connection to the motherboard would send the voltage that the motherboard needs to function, and only that much. And the connection to the CD drive and to the hard drive and all of that, all sends the exact amount of power that that component needs. And then each power supply is purchased by the maximum amount of watts that it can, amount of power that it can supply. So, but the components are only going to pull that amount. So just because you have a 450 watt power supply doesn't mean that you're necessarily pulling 450 watts of power. You're pulling exactly what each of the components need.
Understood.
And when you listen to the last recording, we talked about all of that last class.
Understood, Ms. MoJo.
No problem.
Yes.
Okay. So on page 2-6, it has, if we were sitting in the actual class, then we would have opened the machine so that we can examine the components of the motherboard and the actual form factor of it. But because we don't have that in front of us, but I am going to post a video. I said I was going to post a video, but work has been crazy for me, and I didn't get to post it. I am going to post videos about the power supply in the motherboard tonight when I post the recording before I go to sleep. I'm going to do it. So underneath that, you see computer buses. So in computer terminology, a bus is a communication pathway. A PC has multiple buses to enable communication along the various components of the PC. So just like a bus that rides around, the data travels along the bus. And there's different buses in the system. So a bus is defined by various characteristics, including how many bits it can transfer at one time, which signaling techniques are used across it, and how fast it can transfer data. So there are different bus types in the system, right? So a typical PC has the following buses. It has the address bus, the bus that transmits memory addresses between the CPU and the RAM. The memory controller also plays a crucial role between the RAM and the CPU. And then the data bus is the bus that transfers data between the CPU and the RAM. It's known as the system bus or the system data bus. And then the expansion bus is the bus to which all of the components, the expansion components outside of the CPU and the RAM, that the information goes between those across the expansion bus. So if you think about the different buses, right, the address bus is like the post office, right? Controls the addresses and where everything is going to go and sends that information, right? The data bus is the actual mail, right? That's going from address to address. So the address bus is telling it where to go, and the data bus is what's actually going. And then the expansion bus is like, okay, we got the mail and got the post office, but then it's a whole bunch of other stuff that's in the post office that's not necessarily mail, but all of that stuff is controlled by the expansion bus. I get that, like the extra boxes that they sell or stuff like that. That's not necessarily mail, but it's there and it's happening, and then it's the add-on to the whole postal system. Does that make it a little clearer for everybody, or did I confuse y'all? Okay.
Makes sense.
Okay. So address buses and data buses enable the basic operations of the CPU and its interaction with the memory. So you generally don't have to be concerned with these buses, though their characteristics affect the overall performance of the system. So the address bus and the data bus is going and it's working, and it's not something that you really concern yourself with, but you just know that that's how the addresses and the data flow across those buses. But the expansion bus is the communication pathway over which the non-core components of your computer interact with the CPU, the memory, or other core components. For example, the data sent to and from your computer's hard drive travels over the expansion bus. The reality of the situation is you need a hard drive to have your operating system to be able to put output to the screen where you can see it, but a computer is a computer without a hard drive. You have the board. Just like people put computers together, you don't necessarily need a case. People have built computers in motorcycle chassis, stuff like that. As long as you have the core components, you have power, you have the motherboard, you have memory, you have a processor, right? You have core components of a computer. Of course, you need something for output, so you would need a monitor, right? And something for input, so you would need keyboard and mouse. But the main core components, the power supply, the motherboard, the processor, those are the main components that are controlled by the BIOS, which we'll get into. So, any questions so far? No? All right. Okay, so expansion slots. Each motherboard has slots to accommodate additional components to expand the capabilities of your computer. By installing cards into expansion slots that connect to an expansion bus, you can add new hardware to your PC. For example, your desktop computer might not have come with a wireless network card, even though most of them that they build now do. But for connecting to the network through your wireless router, you can purchase a wireless network adapter card and plug it into an expansion bus to add this capability to your computer. Right? So remember when we showed the picture and it had the PCI spot, right? So here, down here, the PCI slots, right? That's where you would, if you were looking at this board inside the computer, this would be on this side, the left, yeah, I'm left-handed. On the left side would be the back of the computer, so this is where you would see the USB port and the video, where you connect the monitor and all that stuff back here. And usually at the bottom, it's like these little silver plates at the bottom of the back of the case. And you would pull one of those, you can punch those tabs out when you put an expansion card in this slot so that the port of whatever it is that you added is showing out the back, just like these. You guys get that?
Yeah, that was perfectly clear.
Right. So when you would stick the expansion card slot down into the slot, and then the other piece would be facing the back of the computer so that you can plug the Ethernet cable or whatever it is that you're, like if you added a video card and it would have maybe HDMI slots that would need to be shown out the back of the computer so that you can plug the HDMI wire into that expansion slot that expansion card that you just added. So that's how that would be done with the expansion slot. This makes mention of audio modem risers and communication and networking risers. Risers were boards that were added for expansion, right? So they were like cards that you would add to the system prior to PCI to add a modem or add additional audio functionality and networking functionality, but now everything is done in the PCI slots. So they're all PCI compatible, so they come and you just stick it down into the PCI slot and it sticks out the back, as opposed to these different audio modem risers and communication networking risers that we won't see anymore. But that's an old standard that they used to use for expansion. So on the next page, it shows pictures. Oh, and you see it has a PCI card. You see the picture of the PCI card next to the PCI slot, and you see where it has the port. It looks like this was a network card for you to plug the Ethernet in. That's exactly what I'm talking about. So the other side of the card where you see it would be like the card would be green like a motherboard, and it would have like these gold connectors. That's what goes down into the PCI slot, and then this metal part that's on the back is what's showing out the back of the computer. So PCI stands for Peripheral Component Interconnect, and that's what we're going into next. The PCI standard was developed by Intel in 1992. The current crop of PCI adapters and expansion slots generally implement the PCIe or PCI Express. It's like PCI was the original, and then it went from PCI to PCI X and PCI Express, all just increasing the speed, right? So the PCI specification supports bus speeds of either 33 megahertz or 66 megahertz. And it also supports both 32-bit and 62-bit bus design. And that just describes the size of the width of the expansion slot, the bus design. So with the 32-bit implementation at 33 megahertz, the PCI bus supports a peak transfer rate of 133 megabytes per second. Capital B is bytes, small b is bits. They'll talk about that later in another chapter. In the 64-bit implementation at 66 megahertz, the PCI bus supports a peak transfer rate of 533 megabytes per second. And a lot of times when it comes to the CompTIA and the test, they try to focus on the numbers. Like if you have the 32-bit, what's the speed of the 32-bit PCI slot? And it would be the 33 megahertz, as opposed to the 64-bit would be the 66 megahertz. So you'll hear me make mention of numbers like when we talked about the connectors and how this connector might be 15 pins, this connector might be 4 pins. They ask those kind of questions on the test. So that's why I like to highlight the different numbers so that when you're going back and reviewing, you can focus on, you know, trying to remember some of those numbers. So we moved from the PCI standard to the PCI extended standard, right, to address the shortcomings of the PCI, but it increased the bandwidth. Bandwidth is speed for high performance components running at 133 megahertz and transferring up to a theoretical maximum of 1.06 gigabit. Maybe, is that piece supposed to be there? I'm tripping. I think that's a typo. I think it's GBPS, gigabits per second.
Yeah,
that's
I think it's a typo.
Because I'm going crazy. Because that's a typo. It's supposed to be GBPS, which is gigabits per second. And then, like I said, they progress from PCI to PCI-X to PCIe. So it says it's been replaced by the PCIe standard. So the PCI Express uses serial communication instead of parallel communication. So parallel communication was the fact that if it was 8 bits of information going across the bus, it would have to go all across the width of the bus at the same time, as opposed to serial communication means the bits can go one behind the other. in the series as opposed to, parallel. So it says the connection between the PCIe device and the system is known as a link. And each link is a dedicated bidirectional serial point-to-point connection called the lane. So bidirectional means that data travels in both directions, right? And serial means that the information is going, the bits one behind each other in a series as opposed to parallel going in a wide width capacity across the whole board. You guys understand that?
Can you repeat that one more time?
Okay, so the link is the connection between the PCIe device and the system, right? So the link is dedicated, meaning that one, the way that when the information is traveling, it's only traveling in that lane, not all of the information is able to travel in its own lane, as opposed to it was like bits of information going across several lanes in a parallel format. Now it's all in a dedicated lane. The information is going down one lane, but it can go in both directions, which is bidirectional, going to the PCI device and back through the system. And then serial, meaning the information is going in a lane behind each other as opposed to bits across the bus. A little bit better?
Yes, thank you.
You're welcome.
It almost sounded like everything was the same, like there wasn't a real difference between each one. I don't know if you covered the last one. I'm just saying. I mean, I don't know. I didn't catch that totally.
What sounded the same?
The way you explained the link and the bus, and it almost sounded identical. I mean, page 1-8. Somebody's typing something. 1-8, 2-8. Okay, so those are the pages to read. Okay.
No, not 1-8. I think the one was a typo. All right, so what I'm going to do is I'm going to get Peter to come in and into the room and explain the difference between the parallel communication and the serial. If you don't understand it, I thought it was a little bit clear, but maybe I'm not, and I'm fine with that. But I'll give Peter, Peter's been doing this for 25 years, so he can definitely explain it better than I can. But it says that the links can use more than one lane at a time, but all the links must support at least a single lane connection. And it's referred to as by one link. So PCI supports by 1, by 2, by 4, by 8, by 12. And like I said, I'll get more clarification for that for you guys. But what we want to focus on is PCIe is the standard that we're using now, and it progressed from PCI to PCIX to PCIe. So a lot of times on the questions on the test, it would ask which one came first or what's the order of PCI speeds, and it would be PCI, PCIX, and PCIe, as opposed to like PCI, PCIe, and PCIX. PCIe is the the latest and the fastest. You guys got that?
I got it.
Any questions?
No questions. Just an observation. Me being a person of picture. Now I think I would have been better if I saw the picture as you explained. Cause I'm more picture oriented than the verbal thing. Even if the pictures are just words, I can follow along better. Like if you like you have the slots right here. You're showing them. I could have followed better like that, like seeing the words as you explaining it. But that is me. So. But,
do you
okay.
see the words in front of you though in the book? Do you have?
Oh,
you
no.
don't have it.
Yeah. Now to the book, I see it now. Cause, I didn't realize it 2-8. But now I see it on the computer itself. You have posted it. So I didn't know that I needed to go in the book before. That's on my bad on that one. I don't know why but anyway, yeah. So. I saw in the book. I got better understanding of it, a little more understanding, and then I see it on the PowerPoint. So either or would have worked better with me if you went along the PowerPoint, or if I just knew that I had to open the book, which I didn't. For some reason I didn't know that. So, but it was just miscommunication on my part. So.
Okay, I'm gonna try to keep up with my clicking though. Okay, that's my bad too. So I'm going to try to keep up with the clicking of the PowerPoint. It was my assumption that everybody was following along in the book, and I apologize for that. I'm going to try to keep my clicks up with my reading, okay?
So if I'm correct, it looks like PCI was the first standard. PCI X came along and basically increased the speed, but then PCIe came along and increased the speed, and it allowed the information to go in both directions.
Right.
Those would be the main differences.
Yes.
Okay.
And mini PCI was added to create, that's the expansion slots for the laptop.
Okay.
Right, so and the mini PCI is only at the 32-bit. That runs at 33 megahertz. Of course, because it's smaller in the smaller device, right? So the wireless adapters and hard drive controllers, sound cards, and Bluetooth adapters from the laptop all are on the mini PCI expansion slots. Okay, so this book discusses AGP, which is the accelerated graphics port, which is it's an older standard. It goes into detail about the different it's basically, that was the graphics card before they developed the dedicated graphics cards that we use in our PCI expansion slots. This was what you would use for graphic expansions prior to the advanced video cards that we have now, the dedicated PCI video cards that go into the PCI slot. They actually had the AGP slot for additional graphics. It was accelerated graphics, but if you see, it says it has the standards, the 1.0, 2.0, 3.0, 64-bit. It was a port and not a bus because it gave the addition to add to plug into graphics outside of the additional motherboard. Like when you look at the motherboard and you see right now, usually you see the blue VGA port that you plug your monitor into, or if you have HDMI that's on board, it's on the actual motherboard. But if you see it further down where the expansion slots are, then you know that you have a dedicated video card that whatever your display device is would be plugged into. So you guys get the difference between onboard video and dedicated video port. Yes? So AGP was the original dedicated graphics port, right? So it was a direct connection between the video adapter and the CPU, and the original benefit was accessing and using the main system memory, right? Because now video cards come with their own memory, their own fan, everything comes as part of the video card because graphics can pull so much. But AGP was the older standard, and at the bottom you see it says it's being phased out by PCIe because now we have video cards that plug directly into the PCIe slot. And then on page 2-10, it just has a chart that goes deeper into AGP. And this was a picture of the AGP adapter. We're not going to see those because they're not using AGP anymore. But this, if you saw like if you open up an older machine, you'll see the AGP slot is usually brown or black or maroon or something like that. It's one of the darker color slots in comparison to the white PCI slots that you would see on the motherboard. But like I said, newer machines are not using AGP, but if you look inside an old machine and you see this brown slot, you know that's what it was before. That's what it was for, the accelerated graphics port. And that's just more information about the characteristics of AGP that we're really not ever going to see unless you're dealing with a lot of the older machines on, like AGP is really old. Most video expansion is done by PCIe. Like I said, accelerated graphics ports were brown, burgundy, some dark color, some of them were blue. I've seen inside some machines. Multi-function cards, I've never seen a multi-function card, but it was PCI specific, supported multi-function cards up to 8 functions per card, 5 slot cards per system, a total of 40 expansion devices. What you're going to see inside a machine is PCIe slots at this point. So when you focus on expansion, your focus would be on PCIe because that's what, you know, the standards that we're using now. Chipset. So in older PCs, separate microchips were used to provide each individual function. One chip controlled the processor's interaction with the memory, another managed the CPU's interaction with add-on peripherals and so forth. But because of course the complexity of designing the motherboards with separate chips, they developed single chips or the sets of chips. So a chipset is one or more chips packaged into a single unit and sold together that perform a set of functions in a computer. The term is used more often to describe the core features of a computer, which include memory control, system bus functions, audio functions, video display functions, and system management functions. So the chipset doesn't include the CPU. That's another thing. When you are purchasing a board, you have to make sure that when you're purchasing the CPU, it's compatible with the chipset of your board. There's a lot of matching that goes on when you're building the system. So it says each chipset is designed to support a select few CPUs. And sometimes they use the term chipset in reference to video adapter. But more so when you see chipset, it will be in reference to the chipset that's on board on the motherboard that's compatible with whatever CPU you purchase. And most of the chipsets that you'll hear about are the North Bridge and the South Bridge, even though now in more modern machines, the North Bridge is incorporated into the CPU. The functionality of what was the North Bridge is incorporated into the CPU. So two of the most important components of a PC chipset are the North Bridge and South Bridge chips. Together with the CPU, these chips define the characteristics and capabilities of the computer. The North Bridge chip controls interaction among the CPU, memory, and cache. The cache is temporary memory spots, which we'll talk about. AGP and PCIe video control circuitry, and the South Bridge. The South Bridge chip controls interaction between the buses and devices not controlled by the North Bridge, including standard PCI bus, the floppy drive, serial, parallel, and the PS2 keyboard and mouse. So basically, the North Bridge controls the communication between the CPU and the memory and video, and then the South Bridge controls the communication from the CPU to all of the expansion non-core components of the computer. You guys got that? Any questions about the difference between the North Bridge and the South Bridge? Oh, all right. So like I said, more modern systems take into integration even further, transferring most North Bridge functions, such as memory and video control, into the CPU itself. As a result, a motherboard purchased today might have only a single controller hub, essentially an enhanced South Bridge that performs all the chipset functions. So they're doing away with the CPU and the North Bridge and the South Bridge, but a lot of, you'll open older systems that have the North Bridge and the South Bridge, but they're incorporating them into what they call the controller hub. So they're making it not so separated and control, and a lot of things are being transferred to the CPU. So just know that motherboards come with a specific chipset, and that chipset is compatible with a certain few CPUs. Just like you got to match the form factors of your motherboard and the power and the case, you have to match the CPU that you purchased to the motherboard and that chipset. And then the next page talks about front panel connectors. You know how it used to be that all the USB ports and the ability to plug in your mic and your speakers used to be only in the back, but now they have a lot of those connectors in the front along the front panel of the computer. USB is one of the most popular to connect just about every kind of device. So it's always usually a USB ports in the front. Audio, meaning you could plug in your mic or your speakers. The power button is usually along in the front of the computer. The power light, right, is on the front. Drive activity lights, sometimes you see lights, LEDs that flash in the front to let you know about activity going on in the computer, in the reset button. That causes an immediate reboot. Usually, a lot of times you just hold the power button in until the system goes off. But some systems have a reset button in the front that you press to initiate a reboot, as opposed to doing the start and restart from when. Any questions so far about motherboards and the form factors of the motherboards and the chipset and the PCI slots? Any questions? See, somebody asked me something. No questions? You guys just want to run right into the CPU? Okay, so what's the most advanced version of PCI? Yes, Alita, it's very important to make sure that they match. You match your CPU to your board, match your board to your power supply and your case. So the latest version of PCI is what?
PCIe.
Yes, very good, very good.
I'm paying attention.
You paying attention, Sean? So the most popular chipset that they make reference to is what? You just did it. The North Bridge and the South Bridge. Right? North Bridge controls function from the CPU to the core components of the computer. South Bridge controls interactions from the non-core components or the peripherals and things of that nature. Trying to think if there's anything else. AGP, accelerated graphics, but it's really not accelerated because it's old. But that's what it was, accelerated graphics port. But now we know we have video cards that are PCIe, so we don't use AGP. But no, that was the graphic standard, and the ports were brown in comparison to the white PCI slots. I mean, the slots were brown as opposed to the white PCI and PCIe. So now we move to CPUs. I'm sorry, I did it again, right? Yeah. The CPU is the central processing unit. A lot of times people call the tower of the computer the CPU, but that's incorrect. The CPU is the actual chip, the processor, that is the brains of the computer. It processes instructions, manipulates data, and controls the interactions of the other circuits of the computer. And that's a picture of an Intel Core i5, which is one of the most current Intel processors. The I series is their latest series. They have the i3, the i5, and the i7. And processors come in different speeds, and they come, they're more expensive ones. Like you might have an i5 that costs one price, and they have i5s that cost various prices. It's all about speed. So they will be still in that same family, but different levels. Like they have i7 processors that cost $1,000, and Peter will tell you that he has one of those $1,000 i7 in his crazy powerhouse control computer with his 8 monitors. He overdoes it like that. But you'll do the same thing. When you know how to build, then you don't want a simple system. You know what I mean? If you can build a super system, then that's what you're going to build because you know how. For less money than the markup that they would charge you if they sell or whoever built this super system for you. Now you can just shop for the components and build it yourself. So a CPU contains these components: a control unit, one or more execution units, and registers. Single core versus multi-core, we're going to get into that. But the 3 main components: the control unit, one or more execution units, and registers. So the control unit is responsible for managing the flow of a program. That's the component that retrieves the next instruction to be acted upon or the data to be processed. That's the control unit. The execution units are responsible for the processing of instructions and data. Execution units are built from the arithmetic logic unit, the ALU, and the floating point unit, the FPU. The ALU calculates and compares numbers. The ALU does most of the work of the processor, but it's best suited to working with operations that act on whole numbers and not fractions. The FPU is designed specifically to work with real numbers, numbers with fractional components and very large, very small, or very precise numbers. It's faster and more efficient at performing mathematical manipulations than the ALU is. The reality of the situation is all instruction that goes on within a computer is based on binary mathematics. It's millions and billions and millions of ones and zeros. That's it. A bit is either a 0 or a 1. So all instruction that goes through the computer is based on binary mathematics, which you know originates from us. And so the execution units are just what does the math for every process. So you can imagine that it goes through millions and millions of processes to do the things that the computer does. So the older CPUs didn't have the FPU. The one was sometimes offered as a separate add-on chip called the math coprocessor. So it's just a markup to get more money, you know, but the older ones didn't include the FPU, and then the function of the FPU was performed by the ALU, but it was slower. So they had the markup. You could get the FPU, pay a little bit of extra money, and things would go faster. Advancement of PCs is all about speed, getting faster, getting faster, getting faster. Pay more money so that your system will be faster. So a processor can have one or more execution units. A single core processor has one execution unit, and a core is an execution unit. A dual core processor has 2 execution units, a triple core processor has 3, and a quad core processor has 4. So it just gives the computer the capability of performing these separating and doing functions faster, because everything isn't being done by one execution. It's being done by, it's broken down into more than one processor virtually. You have one CPU in your machine, but the different execution units allow for things to function faster and to be able to pull instructions and information faster when you have more than one core. It's just multitasking of the processor. So in a single core processor, the processor orders, executes, and then selectively stores strings of information in its registers. Registers are very small yet very fast memory locations available on the CPU for holding instructions or units of data. Registers operate at the same speed as the CPU, whereas normal system memory can be many times slower. The CPU can access the contents of a register more quickly than it can access other types of storage. So the register, like temporary storage spaces, like the cache, but separate in that the registers are very fast. So a lot of times you see if there's computer errors or if a virus is attacking your computer, it's attacking the register because they know that that's the fastest way for you to get to your computer, as opposed to trying to get to the main system memory. So a CPU can have, they have CPUs with 8 cores now. They're advancing more and more. But I saw recently an AMD processor that had 8 cores. So is no limit. They're being able to separate it and make these functions happen separately is all adding to the speed. How much is it? Well, a guy had one in one of my classes that I teach during the evenings. I think he said he paid a couple of $100, but that's because it's the AMD. AMDs are the less expensive, supposedly comparable processors to Intel, but that's not necessarily true. Intel is the best and the fastest, and AMD is always on the hunt to try to develop a processor to say this compares to the i7 or this compares to the Intel this. But you can research, like if you go on Amazon and you look, you shop for your processors, then you can see the difference in price between a single core, a dual core. The guy said he paid a couple of hundred, so somewhere in 300 or 400, as opposed to thinking about an Intel processor with 5, 6, 7, 8. I think Peter said his has 8, 7, 8. One of them. It costs $1,000 for an Intel one, as opposed to a couple of hundred for an AMD one. So it varies. But Intel is definitely always more expensive than AMD. So during operation, CPUs store data and instructions in registers. That information is then transferred back.
I have a question. Does I guess the 8-core chip has to match with the whole system. Like some chips can't even be put in some systems, like outdated system. Can any CPU fit in any type of computer, I should say? Just a CPU?
Who is this talking? Pierre?
Yes, Pierre.
Yeah.
Yeah.
Remember I said that only certain CPUs can go into certain boards, and the boards are made with chipsets that only accommodate certain CPUs. No, you cannot put any CPU into any computer. Like you would think to yourself, like, I got this old computer, and so I bought this new fast CPU, and I could just put it into this old computer. It's gonna work. No, no.
Okay. What I really mean is, can you find like a 8-core for an old computer to match that? Can you find the same whatever high-speed core to match an old computer? Can you find something for it? Or, they just make the higher cores for the updated computers?
You can only put a compatible CPU into whatever board that it was made to match with. Like, you can't go back and, no, you can't do that. Okay. Specific chips were made to go with specific motherboards. So you can't, they're not interchangeable. They can't, like you can't say, okay, so when I said, can you get a new 8-core processor and put it into an older computer that didn't originally have 8 cores? Was that your question?
Do they make an updated one for an older computer, even though maybe an older computer? Like, no? Okay.
No.
Got it.
The chip, the CPU that is made for your motherboard is the only one that motherboard can take. When you shop for a motherboard, it's going to say it can use these types, this CPU, this one. It'll give you a list, and that's it. And if new ones come out, you can't use those in that motherboard because that motherboard takes this, and that's it. Is it hard to find a match for an older computer? No, you just need to know the specification. They might not make them anymore. They might not be available anymore because they're old, But the reality is technology advances like every 4 to 6 months. So not to say that in 4 to 6 months you won't be able to find a matching CPU for your computer. That's not what I'm saying. But a computer is considered old really quickly, especially Windows computers, as opposed to Macs. You're welcome, Pierre. So the CPU that goes with your system, that's the CPU that goes with that motherboard, and you can't change it. You can only use the ones that are compatible with, and another thing, we're going to get into CPUs, but you'll see the different layouts of the CPUs. Like a lot of the older CPUs had actual pins that you had to plug down into holes to make the connection, as opposed to the LAN grid array, that's what we call a pin grid array, and I'm going ahead. But the newer ones are just like flat, rounded connections, as opposed to pins that had to be like a whole bunch. You'll see the pictures of a whole bunch of pins that had to be meticulously situated perfectly to drop the CPU down into the slot. And the pins sometimes got bent out of place, and then you had to use something to move it back. A lot of times people use an eraser from a pencil to be able to straighten the pin so that it could go back down into the hole. That's why they moved from pins to LAN grid array, which is like the smooth, they look like dots, but the smoothed out connectors that you can sit down into the socket for the CPU. So older systems may be, and then the AMD still uses pins in some of their processors, which is crazy to me. But yeah, so there's a difference between ones that use pins and ones that don't, and so that's why they're not interchangeable. What was made for your board is made for your board, and that's what your board is connected. So like I was saying about the registers, during operations, CPUs store data and instructions in registers. That information is then transferred back to the main system memory. To speed operations, the control unit can pre-fetch information and data from system memory and store them in the CPU's registers. When the processor needs the data outside its registers, it must retrieve the data from the RAM through the system bus or from a storage device, such as a hard disk. This process slows down performance to the maximum speed of the bus, memory, or storage device, right? So the CPU has registers so that it's like the in-between storage space of information and instructions that you use a lot. So like if the main memory or the main storage is the shelf at the library, right? This bookcase at the library. And then you need this information, and the information is the book, right? But this is a book that you use all the time. So you take that book off the shelf and you put it on a table. The table is the register. So you can go back to the table, which is close to you, to pick the book up again, to get the information, as opposed to having to go all the way back down 3 hours over and go through your Dewey Decimal System or what you remember about it to find the book again on that shelf. Y'all get that? It's the same thing with cache. Cache is like temporary memory, putting the things that you use the most in a temporary space so that the CPU can go back to that temporary space as opposed to going and fetching it all the way back from the memory or back from whatever storage device you have. That's why when you're on the internet and it'll be like clear your cache is like the temporary space that gives you the ability for when it auto-fills forms on the computer, or it remembers your password, or it remembers, the different web addresses you go to, because that's stored in the cache, temporary space that you use a lot, and it remembers it until you clear it out. So that's like leaving the books on the table as opposed to always putting them back on the shelf that you got them from in the library. So you guys get the relationship between the CPU and the registers?
Yes, I do.
Okay. So, but the registers The information that's in the registers stays in the register until you change it. So it's that middle space between the CPU or the storage device where the commonly used information stays, like system instructions, stays in the register, as opposed to cache is temporary. It doesn't always stay there. But the register stays there until you change it. That's why a lot of times you see warnings and with your user access controls on your computer, or like your antivirus is like, this is trying to make changes to your registry. Do you want to allow this to do that? You know what I mean? Because that's the pertinent information that stays in that middle space. So you don't want that to be touched or messed with because you're always using it, and it's familiar to your system. So that's why I try to give you a warning when some type of program or whatever tries to change the registry. So, multi-core processor. In a multi-core processor, each core handles incoming strings of instructions simultaneously. When one core is executing instructions, other cores can be accessing the system bus or executing their own string of instructions. To utilize a multi-core processor, the operating system must be able to recognize multi-threading, and the software must have simultaneous multi-threading technology, SMT, or non-uniform memory access, or non-uniform memory architecture, NUMA, written into its code. That's code that gives you the ability to have a multi-core processor, or to use multi-cores as opposed to a single core. SMT enables parallel multi-threading, meaning the multi-threaded instructions are delivered to the cores in parallel. NUMA builds upon SMT by providing separate memory to each processor. Without SMT or NUMA, the software can recognize only one core. So the concept of multi-cores, like I said, is virtual cores. It's not like it's actually separate pieces, you know, but it's software that separates it and creates virtual or simulated separated cores so that it can execute instructions separately in multi. So
can I ask a question?
Whoa, all right. Yes, who's that?
I'm so sorry, but like the gentleman said earlier, I think it would be so helpful that while you're reading, I know you gave us, you know, access to the pamphlets and everything and the information, but as you're reading, it will be so helpful if you just put that page on the screen so that like people like me could just read along with you while we're hearing it. I think I'll be able to retain and understand what you're saying better. You understand? If it's not too much trouble. Like the pages you're reading, if you could just display them on the screen.
But the actual page that I'm reading is not, the words that I'm reading is not on the screen. Like the
I understand.
Like, you know what I'm saying? Like it gives
not
you
the
like
same as the packet.
Right. So it gives you like a table of the different things that I'm discussing, but it's not all of the words and all the information that I'm saying.
Okay, I understand.
Wait. Virtual. No. How do you know if you have SMT software? Does it depend on the Windows version? No. When you purchase your system, it tells you if it's a dual core processor, quad core processor, and if it is, that software is built in. And then the Windows system is able to read it and determine what kind of cores and what kind of processor that you have. When we get into Windows, then you'll see how you look into the system information, and it'll show the different cores of your system and all of that stuff. But it was another question. Virtual court. No, it's not. It's kind of like a virtual disc, but it's just, I said virtual just to give you the concept that it's not like it's the processor separated into separate actual cores, but it's just software that separates the functionality of the processor so that it's able to do, if it's dual, then it's able to do 2 different sets of directions. If it's quad, then it's able to do 4. You know what I mean? It's like not actually 2 processors, or the processor is broken down into separate parts, but it's just software that makes it appear that way and function that way. Okay, good. So a multi-core processor is different from a multi-processor system. In a multi-core processor, the system resources are shared and all cores reside on the same chip. In a multi-processor system, there are 2 separate processors, each with its own system resources. All other components being equal, a multi-processor system is faster than a system with multi-core processor. And you won't really see a multi-processor system. It's just to say that they actually build like servers with a board that accommodates 2 chips as opposed to 1, because they do so much. So they would have one processor that does certain specific functions, and they'll have its own system resources that are connected to that network, and then it has another processor that does totally different functions. It's more for speed, but it's just to let you know that there's a difference between having a system with 2 actual processors as opposed to a multi-core processor, which makes it virtually multiple processors. Y'all get that? So they just differentiate between the fact that when you have a multi-core processor, it's one processor that's using software to make it dual core or triple core or quad core, as opposed to a system that actually has 2 separate chips/processors. Right. A multi-processor system would be the actual real thing, like 2 actual processors. You open up the system and you can see 2 separate processors. That would be a multi-processor system. As opposed to multi-core, you open it, it's 1 chip. But virtually, when you look at it on the system, it has dual core or triple core or quad or 8 or whatever it is. Okay, so processor performance. Where are we in what? So an instruction is a low-level hardware-specific command that the processor acts on. It might be something like add AX and BY to add the contents of the A and B registers. But before this instruction can be executed, a previous instruction must have moved the value of X from a location in memory and stored it in the A register. And then another instruction must move the value of Y from the memory into the B register. One more instruction is required to write the resulting sum back into a register from where it can be transferred to by the control unit to a new memory location. That just explains to you how from the biggest to the smallest thing that happens on the computer is millions of instructions per second. Millions. So you can determine the performance of a processor by examining the number of instructions it can perform in a second. With microprocessors, this amount is usually rated in millions of instructions per second. Millions. CPUs are often rated according to their clock speed. In a PC, the clock circuit keeps the CPU and other chips synchronized so that they can work together. Older CPUs took more than one clock cycle to perform a single instruction. Modern processors perform many instructions in a single clock cycle. So in the time that it takes for the processor, for it to go from the processor to the temporary memory location and back would be the clock cycle, right? So it used to be a situation where every single instruction was done. It took a whole bunch of cycles to get one instruction done. But the modern processors, they have many instructions going in a single cycle. So the clock speed is no longer an indicator of the performance of a modern CPU. By using the technique listed on the following table, a modern CPU can perform more than one instruction per clock cycle and even perform multiple instructions at the same time. So there are many factors that control the actual speed performance of a CPU. Following table describes some of these factors. So on the next page, it gives a breakdown of the design in the relation to CPU performance. One thing you want to always, oh no, I'm not going to go there because that's about RAM. And RAM is one of the fastest ways that you can speed up your computer, but we'll talk about that. So addressable RAM, like I said, the total amount of memory accessible to the processor. The width of the address bus controls the amount of addressable RAM to which the CPU can read and write. One of the simplest ways you can speed up your computer is to add RAM. They'll always be like, you need more memory. If you hear people say that all the time. You need more memory, that's RAM, random access memory. It controls the computer's ability to multifunction and do a whole bunch of instructions at the same time. So a lot of times the issue issues are user errors. 90% of issues that you encounter on a computer is something that the user did. So then it would, they have malware or spyware or something that's slowing the computer down. But to speed up the computer, the addition of RAM is the least expensive way to do that because it adds memory, and memory gives the computer the ability to multifunction and do more functions at the same time. So this chart describes the relation to PC performance. So the address bus connects the processor to the main memory. The wider the address bus, the more memory can be accessed. So we already talked about the fact that data is not transferred over the bus, over the address bus. The bus that connects the CPU, memory, and peripherals is the data bus. The data bus is used to carry data. The width and the clock rate of the data bus determines its data rate. So all of those, is it true you can speed up RAM memory? Yes. A lot of times overclocking is in reference to the speed of the processor, but it is a way to overclock the RAM. But we ain't doing that yet because we ain't even trying to speed up and heat, because you know any speeding up would result in heating up. And that's the thing that you want to be careful about. And speeding up any components of your PC over what it's supposed to do is limiting the life of whatever that component is. So it will be faster, but it would burn out faster too because you speeded it up past what it's supposed to be. The internal bus is the bus that determines how many bits of information the processor can work with at once. The size of the internal register determines how much data the processor can handle at one time and how it moves data around internally within the chip. So all of these different designs determine or add to or take away from the speed of the CPU. So cache is high-speed temporary storage. Accessing data from cache is considerably faster than accessing it from main memory. Various computer components use caches, such as CPUs and hard disks. Processors use level 1, 2, and 3 caching, where level 1 is the fastest and most closely coupled to the processor. Level 2 is less so, and level 3 is even less, yet still much faster than a normal system memory. So like I said, the cache is like those tables, you know, the temporary storage spaces for high speed so that you can go to those spaces to retrieve stuff, well, the system does, as opposed to going back to the main system memory. GPUs, newer processors including Intel Core I series and AMD Fusion have an integrated GPU right on the processor. This unit speeds up video performance, especially for high-end gaming and other graphics-intensive software. So it's like a separate processing unit just for video. And that's why the more advanced processors are in high demand, because everybody is trying to be faster, and then it speeds up the video performance, the GPUs does. Hyper-threading, officially called hyper-threading technology, is an Intel technology that enables each single processor core to execute 2 streams of instructions at the same time, sharing the workload between 2 virtual processors when possible. Hyper-threading is just the ability to multi-core. MMX, multimedia extension, an expanded set of instructions supported by a processor that provides multimedia-specific functions. So that's dealing with your audio and video, is to speed up the audio and video functions of your computer. Without MMX, a programmer might have to implement multiple low-level commands to perform a multimedia operation. With MMX, the same function involves one single instruction. Multiprocessing is the use of more than one processor within a system to speed program execution. Operating systems and applications need to be written to support multiprocessing, or no speed benefits are realized. So you can have 2 processors in your system, but if your operating systems and applications are not written specifically to support that, then it's just like you only had one. Overclocking. Overclocking is running the CPU at a higher speed than it was rated to run. So CPUs are given a specific speed, right? And that's how they operate, at that speed. But you can go into the BIOS and increase the speed. That's what's called overclocking. But then that would also increase the heat. CPUs are already extremely hot. Like, you can fry an egg on it hot, which is why you need the heat sink and the fan. So if you overclock your system, you're going to have to buy a bigger and better heat sink and fan than the standard one that usually comes with the processor. And a lot of people, gamers and techies, like to overclock their system and make it go faster. And that limits the lifetime of your processor. Yes, it's moving faster, but it's going to wear it out faster also. Then you'll need a new one in less time because you overclocked it. And then pipelining, superscalar, throttling, and, well, virtualization, throttling, you'll hear about. Throttling is a technique by which the speed of the processor is scaled back so that it uses less power and creates less heat. Throttling reduces performance. It's most useful in portable computers for which low power consumption and low heat production are critical design factors. So throttling is where overclocking is increasing the speed, throttling is slowing down the speed to reduce the heat and strain and power consumption of the system, and they do throttling of processors in laptops because, you know, you don't want to generate too much heat in that small amount of space of the design of a laptop. And virtualization support. Not all processors support virtualization, a software feature that allows you to run multiple computers on a single system. You will need to access your processor's documentation to determine if it supports virtualization. And that's when Peter was talking about he's going to send everybody VMware. VMware is a virtual machine software. And that would mean that your system has to, you can change the ability to support virtualization in your BIOS. So virtualization, and when you use virtualization software, it's like once you put VMware on your computer, you can actually install separate operating systems within that software so that it will give you the appearance that you're operating another computer that's running maybe Windows XP, and then another computer, because you will add another virtual computer running Linux, and then another one that's running Server 2008. So he's going to issue everybody a copy of VMware, even though, like, we do that for you guys just so that you can learn, you know, faster, and it's something that you would never see in the standard CompTIA A+ class because VMware in itself costs thousands of dollars, the software itself. But, of course, Peter is my hacker extraordinaire, so he knows how to get just about anything. With any program or any type of software that you need, please make sure you ask Peter before you purchase it, because 9 out of 10 times he knows how and where to get it. But virtualization is so that you can, quote unquote, run multiple computers on your single computer. So once we get into VMware, then you'll see that you can add, like I said, a Windows XP, and that's just so you can see the differences, because on the test, it asks you questions about the differences between Windows XP, Windows Vista, Windows 7, it's mostly Vista, XP, and 7. And you will have to be able to explain the difference in the functionality between the different operating systems. And it's easier to do that if you can actually see it. You know what I mean? In a virtual capacity, as opposed to having one computer, having 3 computers, or trying to install, because you can do dual boot where you can have more than one operating system on your computer. But it makes no sense to do that when you can just do it in a virtual capacity and still use it the same way as if you were actually using a Windows XP computer or a Windows Vista computer, although nobody should ever want to use Vista. But yeah. Any questions? Would it be possible to, it's no need for me to unfriend you for me to be able to add you to the group. We'll talk about that. I'll talk about that with you on Facebook after class. I'll get you in there so that you can get all the information you need. Don't worry about it. Apple also what, Rose? Are you asking about virtualization of Apple systems? Oh, yeah, they have a version of VMware for Mac. They do. And you can actually do and put virtual versions of Windows on the Mac too. But that's a separate software. Do you guys have any other questions so far?
No, yeah, I definitely appreciate you.
Oh, thank you. All right, so guys, we are at 10:09. So because the CPU section is kind of large, and it still goes into like up to 40-something pages, we're gonna stop right here and we'll finish this on Monday. So you can, if you like, do the reading on your own, but I'm going to go over, we're gonna continue from this page through the rest of it. We're not always gonna finish a chapter every night because depending on the size of the chapters, some of them are quite large. And then there's other ones that are only like 16, 17 pages. So we'll be able to get through more than one chapter a night, depending on what it is. But I want you to read though, still, even though we're gonna go back into it and we're gonna probably do the questions for the next Wednesday from this chapter. I still want you guys to read. So I want you to come back to the table with questions. And I won't know that you read unless you ask me questions, either in class or through the weekend. Like, Peter hasn't decided if he's going to do a sandbox every week. Originally, it was scheduled for every 2 weeks, but he wants to do, I think he said he wants to do every week. But he'll let you know. He will post it in the room if that's his plan. And it will be Saturday morning if he was going to do a sandbox this week. So, any questions, comments?
Up to how much reading are we supposed to read exactly?
You can read as much as you want. It's 3 chapters. I scanned the next 4 chapters, but I'm not going to upload them yet.
Okay, I guess
you can read through the end of 2 if you want to, and if you want to do the questions, but I'm gonna still go over that information too. But you can read it if you want to, and then we'll get into chapter 3 probably. Yeah, most likely we'll get into chapter 3 too. When we come back to class.
So actually, in order for me to be caught up with the class, or I guess anybody else, reading everything from 1 to chapter 2 would be recommended then.
Yes, you definitely need to do that because you need to see all the information about safety and electrostatic discharge and electricity and power supplies and all that we did in Unit 1. So you'll be all caught up.
Understood.
And I'm going to make sure that the recordings get posted. I'm going to, Peter is the super sleuth. He converts these videos to YouTube videos, and I'm trying to figure out if I'm going to do the same thing. Usually the video format is with what's called an ARF file, ARF. That's the extension, and I'm going to post the link to the page where you download the ARF player, right? So you download the player software, and then you download the recording, and then as soon as you click the recording, it starts playing. So both of them will be in the room, and corresponding videos about motherboards and CPUs and power supplies and safety and all that good stuff. We'll have a whole bunch to watch and go through over the weekend until we maybe get on next Monday. But be on the lookout. Peter, he can't not teach. He acts like he can't, but he's going to want to get together with you guys most likely this Saturday, depending. But he'll let you know. He'll post it in the room if that's what he's going to do.
Okay.
And I told y'all, feel free to send me messages on Facebook, post in the room if you have any questions about anything you read. I look forward to that so that we'll have the discussion there for anybody else who might want to see it.
Thank you. I definitely appreciate that, MoJo.
You're welcome. If there's nothing else, my family, I will see you guys next Monday. And I will see you on Facebook all through the whole weekend because you guys are going to be reading and watching videos and asking questions. So good night to everybody, and you guys enjoy the weekend, and we'll all get back together again on Monday.
All right, thank you.
All right. Good night, everybody.
Night.
Good night.
Good night, people.
Night.
Good night.